Right, so to add or subtract, you have to make sure that your fractions have the same denominator. And if they don't have the same denominator to start, you have to find the LCM, which is the least common denominator first. So let's remind ourselves how that works with, just regular old numbers, right? So what is the common denominator between a 6 and a 9? That's the 18, right? The least common multiple, not the GCF. So the least common. So basically, the smallest number that both of them go into. So the common denominator here will be an 18, right? Well then, so what do I do to the fractions here? In order to make the 6 and 18, I need to multiply it by 3. So I multiply top and bottom by 3. And then the 4 over 9, I need to multiply by 2, right? So basically, you multiply top and bottom by whatever you can multiply it with so that it becomes the LCM. So here, we now have 15 plus 8, 23 over 18. Okay, great. So take a look at this next one. Let's find the LCD, the least common denominator, right? So what you first have to do is you have to factor this one. When you factor this, what do you get? X minus 2, X minus 1. What about here? This will be 2 times X squared minus 1, right? And when you factor it, you get X plus... Right, you factor out a 2, and then this becomes 2x plus 1, x minus 1. All right? So now, what's going to be the least common denominator? So basically, take a look at what we have here, right? What do we have here? We have in here an x minus 2 and an x minus 1. Here I have x minus 1, x plus 1, and a 2. In order for you to pick the LCD has to be representative of everything here. So basically, you have to have samples of everything that you have here. In other words, you have an x minus 2, that goes into your LCD. Now look, you have an x minus 1, that also goes into your LCD. Now let's go to the next one. The x minus 1 repeats here, right? I already chose an x minus 1 in my LCD, so I don't have to repeat it. But then what else do I have? I have an x plus 1, and I have a coefficient of 2. So all of that is my LCD. Okay? So basically, everything here has to be represented in your LCD. The LCD is inclusive so that all of your denominators can go into it. Okay? All right. So basically, you look at all of the factors.
What happens to the 2?
The 2 is here. Okay. So let's take a look at here. What is going to be the LCM of these? So first, let's do the fraction. Let's do the coefficients. This is a 15, which is a 3 times 5. This is a 16, which is 2 to the 4. This is a 20, which is 5 times 4, which is 5 times 2 squared. Yeah? Okay. So now, take a look. I have a 3, I have a 5, and I have some 2's, correct? Okay, I take a sample of the 3. The 5's, I have a 5 here and here, so I take a sample of the 5's. The 2's, I have one that's 2 to the 4, one that's 2 squared. I have to take the higher of the 2, so I take the 2 to the 4. Okay? Now, let's take a look at the variables. I have an a squared and an a cubed. I take the one with the higher exponent, a cubed. What about the b's? I have a b to the 1, b to the 5. I take b to the 5, and the c's, c to the 6th. So that's my LCD, but then of course you have to simplify that. So all this will become 240 a cubed b to the 5 c to the 6. Yep.
I'm just confused on like why did you choose like those numbers to make the 240?
Well, because look, in each of the terms you had, in these terms, look at the numbers. You have to you have a 3, you have some 5s, and you have some 2s. You have to take one sample of each. So you have to have a 3, you have to have a 5, and then you also have some 2s. You have to take the one with the higher exponent. Okay? Yeah.
Why did you make them into exponents?
Because technically, like the background is you do the factor tree, and then you write them as like the exponents, right?
So whichever one you could export to,
Right.
do the highest?
Yes.
Because you could do 4 squared.
No, you have to do
small
the
base.
prime factors. You have to do the prime factors. So 16 is what? It's like, it's 8 times 2, right? And then this is 4 times 2. And then you have to go a little bit more, so until it's all just prime numbers. And then this is 2 to the 4. Okay? All right, so let's do the next one. Here, we need to factor this one. So you get x times x squared minus x minus 2. And then when you factor some more, you get x minus 2, x plus 1. This one is basically x minus 2 squared. Okay, you see how now it's important when you factor it to combine it and do like a quantity squared, right? Because for the LCD now, or the LCM, they're the same. You're gonna pick one of every different factor that you have. So I have an x, I pick one of those. Of the x minus 2's, which one do I take? X minus 2 squared, and then I have an x plus 1, so I take that one as well. Okay? So now, whichever one of these you take, like whether it's this expression or this expression, everything that this factors into is represented here. And everything that this factors into is represented here. Does that make sense? Okay. So now, adding and subtracting is basically the same sort of thing. You have to write everything in terms of the LCD, and then you have to add or subtract. Okay, so let's see what the LCD here is going to be. All right, so we're going to have 2 fractions here. Let me actually make it like this down here. Okay, so what's the LCD going to be? So take a look. Between the 6 and the 14, the 6 is 2 times 3. The 14 is 2 times 7. So what do you think the LCD will be? 2 times 3 times 7. 2 times 3 times 7, which is how much? 42. Okay, so you know what? Let me write the LCD up here. So it's 42. Okay, and then I take a what? A squared, B squared. Okay, so A squared, B squared, 42, A squared, B squared. Okay, now comes the addition part. Okay? All right. So look at your 6b and compare it to the LCD. What do I have to multiply this with so that it's the same thing as this? Another way to ask it, if I divide the common denominator by this, what do I have left over? So 42 divided by 6, I have a 7. Whoa. I have a 7 times a what? A squared, B, right? So I multiplied this one as well, 7A squared, B. What about the next one? If I divide the LCD by this, what do I have left over? I have, what's 42 divided by 14? 3, and that's it, right? So multiply by 3, multiply by 3. So finally, I have here 35, A to the 4, B, and then 27. So let's combine it into one fraction. This is going to be 35, A to the 4B plus 27 over this. Okay? Huh? You can't combine them because they're different. They're not like terms. Okay, so this next one, let's factor this one. I get 3 times x minus 5. And here I get 6 times x minus 5. So what's the LCD going to be? X minus 5 times what? Does it have to be 18 or what's the least common multiple? Oh, x minus 5, sorry. 6. Between the 3 and the 6, what's the least common denominator? Just a 6. Okay, so now what should I multiply the first denominator with so it's the same?
2 over 2.
Right, so this divided by that, you have a 2 left over. So I'm going to multiply this by 2.
I don't get how it's 6.
Oh, wait, never mind.
Huh?
I don't get how it's 6.
Okay, between the 6 and the 3, what's the common denominator?
Oh.
A 6, right? Yeah. Okay, so we're going to multiply that by 2 and this by 2. Okay, how about the other one? What do I multiply by?
1.
Nothing, a 1, right. So this is going to be 2x plus 20 minus, in parentheses, 3x plus 15. So this becomes 2x plus 20 minus 3x minus 15 over this. So what is that, negative x? Ugh. Okay, so it's negative x plus 5 over 6 x minus 5. What now?
You do 5 minus x and then make it -1.
Yes, you can. So this is actually 5 minus x, right? If you just rewrite it in different order. Yeah? And now, look, 5 minus x minus 5 go away, and it's minus 1. So finally I have minus 1 over 6. And who would have thought that complicated thing just reduces to negative 1 over 6? Okay?
And if you check, can you put -6?
There is no checking because it's not an equation.
Oh, yeah.
Yeah. Okay, so take a look. Okay, so let's do this next one. Let's first factor x minus 3, x plus 2, 5, x plus 2. Okay, so what's the common denominator going to be? 5x minus 3, x plus 2. You need to take one of each. Okay, you know what, can we make things a little bit more efficient? I'm just gonna, because in the end we're gonna combine it into one fraction, I'm just gonna combine this into one fraction from now. So it's gonna be 5, x minus 3, x plus 2. Because the more you have to repeat writing the same thing, the more chance that there is a mistake made, okay? Okay, so what do I multiply the first fraction by? 5, okay? So 5 and 5, so this is gonna be 5 times x minus 1.
Why do you want to put that?
So compare this first denominator with the LCD. So like this divided by that, you have a 5 left over. In other words, if you'd better make this the same as, okay, so now this into here, what am I going to multiply by? X minus 3. So here I get minus 4, x minus 3.
How did you get that?
This x minus 3? Okay, so compare this with this, right? What should I multiply this by in order for it to look like this? Look at this. 5 times x plus 2. What do I multiply this by so it looks like this? Yeah? Yeah, so here we're going to get 5x minus 5. I'm going to distribute a negative 4 minus 4x plus 12 over this cute little thing.
Can't you cancel out the x minus 3?
No. You cannot cancel this x minus 3 with this because this is being added to or subtracted from something else. So you cannot do this. Okay.
So it's like simplify the top and the bottom.
Yes, you have to simplify. You have to distribute. So what do I get now? Here, 5x minus 4x is x plus 7 over this, right? Okay? All right, let's do another one.
And when do you know if you can just multiply to the top, the bottom to the top, like we did in the last one?
What do you mean?
Like the last one we multiplied x plus 5. So it's the bottom to the top.
So we didn't, we canceled them because we had 5 minus x on top, x minus 5 on the bottom.
So you
We
can
can.
cancel?
No. You just had a 5 minus x here. It wasn't 5 minus x plus something or minus something.
Oh, okay.
That's why we could
So
cancel.
like at the end you can.
Yeah, but here it's x minus 3 minus something else, so you can't. Okay, Julian, you with me? Okay, so let's do this next one. What's the, so first we're gonna factor. When you factor this, it becomes 4x plus 1 and x plus 5. And this becomes 3, 4x plus 1. So what's the LCD gonna be?
3 times
3?
plus 1 times x plus 5.
Correct. Okay, so now look. Compare this LCD with the first denominator. What's extra here? 3. So I multiply this by 3. Okay, compare the LCD with the second denominator. What's extra? X plus 5.
And the ones you get, maybe the ones you give us, so we do like this all the time.
Say that again.
Like the ones that you're gonna give us on like the quiz, for example, are you gonna give us like examples like this?
Like, I mean, eventually things are going to get a little bit more challenging.
Like when we get calculators for those.
Oh no. Calculator?
Why would we need a
Oh
calculator?
no.
I didn't know that.
No. Listen, by the time things get more complicated, you will also have gotten more masterful at it. So don't worry. 9x plus 6 over, is that right? Over 3, 4x plus 1, x plus 5. Oh, but look, I can factor out a 3 from here. So I get 3x plus 2 over 3, 4x plus 1, x plus 5.
Like, it wouldn't be over 3.
Mm-hmm. This 3,
Can't you just cancel?
now it cancels. So what do I have left? 3x plus 2, 4x plus 1, x plus 5. Yay! I legitimately love these. I really just love these. How satisfying is this? Okay, it does get more fun with practice, I promise you. Right? And you're just like, cancel, can't, right? Yes. You just have to like make sure to not get like cancel happy. Okay, now Daniel. I might be older, but I got pretty good hearing. Okay, so complex fractions. Remember, this is when you've got a fraction within a fraction, right? Okay, so okay, so there is lots of different ways to do this, and I want you to be comfortable with both of them, okay? So the first way is we're gonna do each one as a separate mini problem of its own. So for now, let's just focus on the numerator here. What is the LCD between the A and the B? It's AB. So the first fraction, I multiply by B over B, and the second one by A over A, right? So what do I get? B plus A. Okay, now let's go to the bottom. The common denominator is what? This is 1 over 1. It's B. So it's going to be, so I multiply by 1 over 1, and then B over B, so it's 1 minus B, correct? Now, look at what I have. I have something divided by something else. So this is B plus A over AB times the reciprocal, right? These go away. So I got b plus a over a, 1 minus b. How does that sound?
Where you get the 8?
Sorry,
Where you
I
get
was just so excited.
Don't you go 1 minus 3?
The a goes, this is the a here.
Are you allowed to cancel the b out?
So,
Yeah.
so for this one, you don't have to, you can like simplify before you.
Okay, you really need to take notes.
This is a minus b crossed out with the b.
Huh?
This is a minus b crossed
Julian.
out with the b.
No, this b cancels out with this b.
But does the minus b not cancel out with the other b?
No, because that's 1 minus b. It's an entity together, so this can't cancel out. Okay? We're good with that? Okay. So this is method 1. I really want you to know and be comfortable with both of these. Okay, let's look at method B. Okay? Or method 2. Let's be consistent. Okay. So for method 2, okay, let's take a look at all of the denominators, right? Here I've got a denominator of x. That's just the 1. Here I've got a y and an x. Between all of these, top and bottom, what is the LCD? I've got an x, a y, and an x. What is the umbrella LCD? It's xy. So what you're going to do is you're going to multiply this whole thing by xy over 1, and this whole thing by xy over 1. Now, be careful when you do this because you've got to distribute. So, xy over 1 times 2 over x is what?
2xy.
It's 2y, right? Minus. Now, this times the negative 1 will be negative xy. You see how the fraction went away? Now, multiply this with this. What do you get? X. Minus, multiply this with the 3 over x. What do you get? 3y. Okay? So now, can we factor anything else out? No, we can't, so we're done. Okay?
Can we do y times 2 minus x?
Okay, so you can factor out a y here, and you get 2 minus x, and then you have x minus 3y. But in factoring out a y, are you then able to cancel things out? No, so you don't have to factor out. You can very well leave it like this.
You can't cancel out?
Huh?
You can't cancel out?
Nothing here cancels out. Nothing here cancels out.
Wait, so then, why do you cancel out over there?
Because look, it's b plus a times b.
So that was AB.
Right, but these are all being multiplied by each other, right? So here, b plus a times b over a times b times 1 minus b. They're all being multiplied, right? The terms aren't being added to or subtracted to. So either of these are okay. Okay.